Okay, you can read through this little note on the Z-score, but what I want to talk about is just a little bit about what it means. On the back of, it says that in your textbook, page 606 and 607 are the Z-score tables. And the concept here is that we're able to create a Z-score with a standard deviation of 1, and we sort of superimpose that upon any normal distribution. And it allows us to be able to calculate the percentages underneath the curve. So in this particular case, our Z tables, notice that they're showing the region to the left of our Z score. So this is the Z score here that we're talking about. This is the value that we're referring to. And in each case, it's talking about the area under the curve to the left, or in other words, below the value. I'll show you when we do a sample question how we look up the values within the table. But that's essentially what it means. And when we see our example question, I think it'll make even more sense. So let's get started onto our example 2. Just to finish this note, the distribution of the Z-scores of a normally distributed variable is a normal distribution with a mean of 0, right? So a mean of 0 and a standard deviation of 1. So in the case of our heights of students, instead of having an average height of, say, 186 centimeters, it's like we sort of shift the curve down. If this was 186, it's like we shift it down to it's a 0, and we compress it so that the standard deviation, whatever the standard deviation was on our heights, becomes 1 on our Z-score, 1 on our Z-score. And the more you work with it, the maybe more you'll understand. But the concept is that we're basically sort of superimposing whatever question we're looking at onto a standard Z-score table. And it's kind of almost like calculating a percent. So in this case, this particular distribution is often called the standard normal distribution. And as I said, once we start doing some questions, I think it'll make a lot more sense to you. Areas under this normal curve are known to a very high degree of accuracy and can be printed in table format and can be found in the textbook, page 606 and 607. So let's take a look at our first question. Here we're told that class marks are normally distributed with a mean of 70% and a standard deviation of 4%. Use Z-scores and the standard normal distribution to determine the probability that a randomly selected student will have a mark less, that's going to be to the left, than 65%. So all we need to do, first of all, is to find out, well, what is our Z-score? We know from our last unit that Z is equal to our X value, subtract the mean, divided by our standard deviation. All right. So in this particular case, my X value is less than 65%. That's my X value that I'm interested in. My mean is a 70%, which means it's a 0.7. And my standard deviation is a 4%, which is 0.04. So when I do, to calculate my Z-score for that, I get X is X is 65%, of course, would be 0.65. So 65%, our X value is 0.65, subtract our mean of 0.7 over our standard deviation of 0.04, and this yields a Z-score of minus 1.25. So how do I use my tables on page 606 and 607? Well, I found one on the web. It's the same table. We said that my Z-score was minus 1, so I find my minus 1. Here's minus 1 here. Minus 1.25. So this is minus 1. Here is minus 1.2. So I need that, but I need minus 1.25, and the 0.05 is there. So minus 1.25 becomes that value right there, which is 10, it's hard to see. I'll have to look on the computer. 1066 maybe? 1056. I couldn't see on the smartboard. So that has a value of 10.1056. So our probability that our X is less than 0.65, that our percentage is less than 65%, is really the same as the probability that our Z is less than minus 1.25. And I know from my tables, less than, that Z is less than negative 1.25. That's the negative 1.25. And I found on my table that a z-score of less than minus 1.25 was 0.1056, or in other words, it's a 10 point, I'll round it to 10.6% chance. All right, let's take a look at a second question. Maybe there was a previous, was there? Oh, great. Okay, so what is it if it's greater than 80%? So greater than 80%. Again, maybe I should have drawn a graph on that previous question. Let's take our little graph. We know that we've got a normal standard distribution. And what we're talking about is an 80% question here. Right? So if it's greater than 80%, I'm talking about that area of my graph. We know that the mean was 70%, and our standard deviation was 0.04. Right, so this is sort of a 74, 78, 82. So this is sort of one standard deviation. That's one. This is two standard deviations, and this is three standard deviations. So we're using our z-scores because it doesn't happen to land exactly on a 1, a 2, or 3 standard deviations. If it was, we would know is that we use the rule of 65%, 95%, or what was it, 99.7%? Yeah. But it's not, so we can't use one of those three rules, so we have to calculate our z-score. So what we want to do is we want to superimpose this value. What would it look like on a z-graph? So my z distribution has a mean of 0, and we got to calculate what is our z-score here. I don't know what it is. So I need to calculate what that z-score is. So I use my formula, z is equal to my point x, subtract the mean over the standard deviation. We're talking about 80% in this case. So my x is 0.8, subtracting my mean, which is 0.7, over my standard deviation, which is 0.04. This gives me a standard deviation of 2.5. Excuse me, this gives me a z-score of 2.5. So what I'm trying to calculate is finding a z of 2.5, and I'm interested in this area above 2.5 because I'm looking for greater than 80%. So the probability that my percent is greater than 80% is the same as the probability that my z-score is greater than 2.5. And I can compare this because we're told that it's normally distributed. This is what allows us to do this. So now we know that our z-scores are really telling us the areas below our value. And we know that all the areas under the curve have to sum to 1. So this allows me to say that that's really the same as 1 subtract the probability that my z-score is less than 2.5, right? So the whole area under the curve is 1. So 1 subtract this blue area is going to be the area above the curve. When I look at my table, I'm looking for a value of 2.5. So here is my 2.5 right there. So that is my z-score, 2.500. So this becomes 1 subtract 0.9938, or 0.0062. So therefore, my probability that my score is greater than 80% is going to be 0.62%. And finally, we'll do a question where it's between two scores, 65 and 80%. Looks like I'm going to run out of time. I'll pause this. I'll stop this and look back at the question on the next video.